Hello everyone, this is Virendra from iDeserve. Today I'm going to talk about palindrome partitioning using minimum number of cuts. For string S, we need to find out minimum number of cuts required to separate the string into a set of palindromes. For example, this string ABCCD can be split up into 4 parts which are palindromes using 3 cuts, and banana can be split up into 2 parts which are palindromes using 1 cut. If you observe closely, you'll see that banana can be split up into multiple palindromes, right? Here, if you cut after B and then after A and then after N, you will have like 1, 2, 3 and 4 parts, right? But you are ending up with 3 cuts. However, that is not the optimal number of cuts. The minimum number of cuts to split up banana is 1. That is what we need to figure out, right? The minimum number of cuts required to split the string into a set of palindromes. Let's look at the approaches. If we follow a brute force approach to check all the substrings, we'll end up with order of n cube complexity, right? We definitely don't want to do that. We are going to use dynamic programming, which would give us order of n squared time complexity. So let's go ahead and first try to understand how to detect a palindrome. To detect a palindrome, there are 2 conditions. If the first and the last characters match, and if you trim out the first and the last characters, the remaining substring should also be a palindrome. A single character is always a palindrome. If you look at this particular string NAN, the first and the last characters match, and if you trim out the first and the last characters, the remaining character, which is A, is also a palindrome. Now we know that NAN is a palindrome. Let's look at another string ANA. This is also a palindrome because the first and the last characters match, and if you trim out the first and the last characters, the remaining substring, which is NAN, is also a palindrome. So this is the concept that we are going to use to figure out the palindromes, substring palindromes inside the whole string using dynamic programming. To do that, we are going to have a table where the rows and the columns are represented by the characters of the given string. So we are going to do character by character comparison for each substring of length 0 to length 6. Okay, so let's start with substrings of length equal to 1. We know that strings of length equal to 1 are trivially palindrome, so B is a palindrome, right? So we set the value true for all single character palindromes, and then we move on to substrings of length 2, and we compare the first and the last characters. As soon as the first and the last characters do not match, the first condition fails. We set false for that particular substrings. The same thing happens for all the substrings of length 2. The first and the last characters do not match. Let's go ahead for the substrings of length 3. Here also the first and the last characters do not match, so we set false here. If we move ahead, we see that for the substring ANA, the first and the last characters match. So we'll trim out the first and the last characters, and we'll try to check the second condition, which is basically the substring which is extracted from the original string. Is that a palindrome? Let's check. Yes, it is a palindrome. Since that is a palindrome, the whole string will end up being a palindrome. Let's look at another substring. Here also the first and the last characters match, so we trim out those characters and look at the remaining substring and see if it is a palindrome. It is also a palindrome, right? So the whole substring will be a palindrome. Again, we found another palindrome here. Let's go ahead for substrings of length 4. Here the first and the last characters do not match, so we skip this substring. Let's go to the other substring. Again, the first and the last characters do not match, so that is not a palindrome. The same thing happens for the last substring of length 4. Let's go to substrings of length 5. Again, the same case. First and the last characters do not match. B is not equal to N, right? Let's go to the last substring of length 5. We see that the first and the last characters match, A equal to A. We trim those out, and we have a remaining substring of NAN, right, which is basically a palindrome. So the whole string ANA will be a palindrome. Okay, so we set true for that. Now let's look at the string of length 6, which is the whole string. The first and the last characters do not match for that. That's why the whole string is not a palindrome. We set false for that. Now we have a Boolean table which determines if each substring is a palindrome or not of the whole string, right? We are going to use this information to figure out the minimum number of cuts for the string to be split up into a set of palindromes. But before going there, let's look at the code for generating this table. The code is pretty straightforward. Initially, what we are going to do is we are going to cover the trivial case where we are going to set all the single letter palindromes to true, and then we are going to look at two character palindromes and see if the first and the last characters match. If they do, we'll set true. But in this case, none of the two letter substrings are palindromes, so all of them are set to false. For the rest of the substrings from length 3 to length n, we are going to check if the first and the last characters match. If they match, and if the remaining substring, that is I plus 1 and j minus 1, we are comparing I and j, right? Ith and jth character, the first and the last character, and then we are also checking if the rest of the substring, which is basically trimming out the ith and jth character and having I plus 1 j minus 1 substring, if that is a palindrome. If both these conditions are true, we are going to set palindrome ij equal to true. So we do that for the rest of the substrings. We are going to use dynamic programming twice in this. First time is to figure out palindrome truth values for each substring of the whole string, and the second time is to figure out the minimum number of cuts. So once you have this palindrome table ready, what you can do is you can start splitting up the string into multiple parts and check if those substrings are palindromes from this truth values, right? So let's maintain an array where we track the number of cuts required for each substring. For example, if you are looking at this cell, you are only looking at the substring B. If you are looking at this cell, you are looking at substring BA. This cell denotes the minimum number of cuts required to split up this substring BA. Okay. Similarly for BAN and BANA and so on. Okay. So let's start with B. B is trivially palindrome, right? So we don't have to split it up. The number of splits or number of cuts required for that is 0. Let's go ahead for a substring of length 2, which is BA. Before cutting it up, let's check if it is a palindrome, right? Let's see in the table. In the table it says that it's not a palindrome, it's false, right, for the whole string. So we need to split it up. So we are going to cut it here and see that it's split into two parts, right, B and A. We already know the number of cuts required for B, which is stored here, which is 0, and for A we need to check if it is a palindrome, right? So we'll check from the table. It is a palindrome, right? From the table, this cut is useful for us, so we need to keep this cut. The number of cuts for the whole string BA is 0 plus 1, right? Let's move ahead to the substring of length 3, BAN. First of all, we'll check if the whole string is a palindrome. If it is a palindrome, we don't have to split it up, right? So we'll check if that is a palindrome. No, it is not. So we need to split it up. Let's split after the first character. Okay. So now we have two substrings, B and AN. We already know the minimum number of cuts for B, so we don't have to do anything about it. Let's look for AN. We don't know the number of cuts required for AN, right? So let's look for it in the table. If it is a palindrome, we won't require any cuts for that. AN is not a palindrome from the table, right? What we need to do is we need to split it up further. Let's split it here. Okay. Now we have two substrings again, A and N. We already know the number of cuts for the whole substring BA, right, which is 1 here. We don't know the number of cuts required for N, right? Since N is a palindrome from the table, we don't require any cuts for it. Okay, but we have already done a cut to obtain N, right? So we add 1 to this because BA requires 1 cut to be split up into a set of palindromes, right, which is here. We add 1 to that so that we get a set of palindromes for the whole string BAN, right? So this is basically reusing the values that we have computed before. So we are applying dynamic programming here, right? Let's move ahead to substring of length 4. Here let's see if the whole string BANA is a palindrome from the table. Okay, we see that it's not a palindrome, so we need to split it further. Again, we split it here and then we obtain two substrings B and A and A. Let's check for A and A in the table. A and A is a palindrome, right? It is true. So the number of splits required for the whole string B, A and A will be 0 plus 1, right? So the whole string can be split up into two palindromes B and A, right, using one split. Now let's try to see if we can find another minimum for this, right? Definitely we are not going to find it. Just for the sake of it, I'm going to go ahead and do another split. If we split it up here, we'll get two substrings BA and NA. For BA we have already computed here. For NA we haven't computed it. Let's check if NA is a palindrome. No, right? So this is not a valid split. Let's go ahead and split it further. For BAN we know that the number of splits required to split it into palindromes is 2. So for A here we don't need any splits because it is already a palindrome. So for the whole string BANA we would require 3 splits if we split it here, right? So the earliest split that we did, which was at this point, we had a substring of B and A and A. That was a better split, right? Otherwise we would end up splitting it 3 times, here, here and here. So it's better to split it here, which is basically the minimum number of cuts for BANA, which is equal to 1 if we split at B. Now I'm going to skip the substring of length 5. I'm going to directly go to the whole string. Let's start by looking at the whole string. If it is a palindrome, we won't need any cuts, right? But it is not a palindrome. Let's split at the first character. We have two substrings B and A, right? For B we have already computed here. The number of cuts required is 0. For A, we need to check if it is a palindrome. If that is the case, we will require 0 cuts for this particular substring. A is a palindrome, right, from here. So we won't require any cuts for this. So the total number of cuts for this whole string BANA, which is banana, is 1, right? 0 plus 1. Okay. If you cut any further and if you try out all other possibilities, this will be the minimum number of cuts required, which is equal to 1. The last column value of this cuts array is our answer. So let's look at the code here. So this is the cuts array that I have mentioned earlier. Each index of this array maintains the value of minimum number of cuts for that length of substring, ith length of substring, right? So the length of the substring we are looking at will go from 0 to n. I is the length of the substring, okay? And in this temp variable I am going to maintain the minimum number of cuts that I am going to track for that particular length. We should first check if the substring of length I is a palindrome before splitting it up, right? If it is a palindrome, then the number of cuts required is 0. Else start splitting up the substring of length I at each character and see and try to figure out the minimum number of cuts for that particular substring here in this loop. Finally, we'll have the number of cuts for the whole string in the last column of the cuts array, right? That's all about the code. Please check out the GitHub link here. Thank you for watching the video. I would like to specially thank James for suggesting this question. I would also like to encourage all of you who are watching the video to please suggest any problems or topics that you are interested in. We would like to make videos for them as well. Thank you again. Stay tuned and subscribe to the channel. I deserve. Thank you.